Guys, welcome to Mobile Maths with Kamchrai. Today I want us to look at geometric sequences. Okay, so here I would like us to go through a couple of questions. Before we do that, we are going to use these formulas where we have our R. This is our common ratio. I say common ratio because you find out for every term in the sequence you get the same ratio. That's why I will be saying common ratio. So for this one, let's say we have got our n as 2. It means this formula becomes T2 over T2 minus 1, which is simply the same as T2 over T1. Okay. Then for us to get the nth term, we will use, say we want to find the second term. It means our n is equals to 2. And this formula here becomes T2 is equal to A R to the power of 2 minus 1. And you simply have, at the end of the day, A to the power of R there. That's T2. That's how you do that. Okay, let's have examples, real examples, so that you see how we apply these formulas. Okay, I've got this question here. We want to find the sixth term of the sequence. So for this sequence, this is T1, this is T2, this is T3. Okay, and the first term here is always A, which is the first term. So we want now to find the common ratio. Common ratio, we said our common ratio is equals to R is equal to Tn over Tn minus 1. So if I use 2, n as 2, it means this becomes T2 over T1. Okay, so substituting with what we have, I will have T2 6 over 2, and we'll get our common ratio as 3. Okay, so this is our common ratio. So we now have A as 2 and our R as 3. Okay, now we go to our formula which we use to find the nth term, which is T n is equals to A to the power of R n minus 1, like this. So for this one, we can substitute with the information that we have. So they said we should find the sixth term. It means our n is equal to 6. Okay, so we substitute. So we have T6 is equal to A. We said our A is 2. Let's have our 2. R. Our R we said is 3. So let's substitute there. So we have got 3 to the power of n is 6 minus 1. Okay, like that. So let's simplify that. And what do we have? We have got T6 is equal to 2 times 3 to the power of 5. Okay, so if we punch in our calculator, we find our T6 as 486. So this is our sixth term. Okay, let's have another example. Okay, this one has got fractions. Which term of the sequence is equal to this term? Okay, so we do the same. We find our A and our R. So remember, this is our T1, T2, T3, and so on. So our T1, we always say it's our A. So our A is equals to 20. We now want to find our R. Our R, we said, is T2 over T1. Okay, so if I do that, I can have minus 4 over 20. And if we divide that, we end up having minus 1 over 5. Okay, as our R. Now let's go on to use our nth term equation. Tn is equal to A R to the power of n minus 1. Okay, if we use that, we don't know the nth term, so we are going to equate with the number that we are given, or the value that we are given. We were given 4 over 125. This is equal to A, we know 20, R we know minus 1 over 5 to the power of n minus 1, there, like that. Okay, so now what we are now doing at the end of the day is that we now want to simplify this. We now have to simplify this. That's now our job here. So for starters, I can divide both sides by 20, or I can multiply both sides by 1 over 20 by 1 over 20. This is 2 by 1 over 20. Okay, such that on this side, this one will cancel off with that one on the right side. This one, 4 into 20, we get 5, and I can have 1 over 625 here. 1 over 625 is now equal to minus 1 over 5 to the power of n minus 1. Okay. Having that, we can further simplify this. 625, this 625 here is the same as 5 to the power of 4. We get 625. So I can use that to my advantage. Let me do that. So I can have, at the end of the day, 1 over 5 to the power of 4 is equal to minus 1 over 5 to the power of n minus 1, like that. Okay? I think this is clear. Okay, having this, let me write somewhere else. 1 to the power of 4 will get 1. So I can write this as 1 over 5 to the power of 4. Okay. And is equal to minus 1 over 5 to the power of n minus 1. Okay. Okay, I think it's clear. Now, then the other issue, when we have an even power like this one, this is an even power. Even power. It means, for example, if I say 1 to the power minus 1 to the power of 4, I'll get 1. And if I say 1 to the power of 4 like this one, I'll get 1. So I can introduce a negative so that it will be similar to this side. So I can have minus 1 over 5 to the power of 4 is equal to minus 1 over 5 to the power of n minus 1. Okay, because it's an even power. Okay, now having that, it means I now have the same base there. So I can equate these powers together, and I can have my 4 is equal to n minus 1. Okay, and at the end of the day, we have our, this one goes that side, we add, we have 4 plus 1 is equals to n, and we have our n is 5. Okay, so we have our n as 5. Now let's have a look at another example. Okay, this one we have got T4 is T5, T6. So now if we have T6 like as 3x plus 1, we want to find the value of x. So we are going to use the formula for our ratio, common ratio, which is R is equals to Tn over Tn minus 1. Okay, so you notice that if we have, if I want to find the common ratio or the common ratio for T5 and T4, I'll get an R there. If I do the same for T6 and T5, I'll get an R. The ratio there will be different, will be the same. Okay, so if I say T R is equals to T5 over T4, this is the same as T6 over T5. Okay, we will get the same common ratio. So with that information, I can equate these two like this. And now I can substitute with x minus 4, x plus 2, and 3x and find the value that we have. Okay, so let's do that. Substituting what we have, I've got T5 as x plus 2 over T4 x minus 4 is equal to T6 is 3x plus 1 over x plus 2. Okay, now what we can now do is cross multiply. I can cross multiply this and have this one multiplying with that and this multiplying with this, such that I have got x plus 2 multiplying x plus 2, and on this other side I'll have 3x plus 1 multiplying x minus 4. Okay, like that. Okay, so having that, we can now remove the brackets. Let's remove the brackets for this. Okay, removing the brackets, it means I'll multiply x by this whole bracket. So I have x by x plus 2, then plus 2 multiplying x plus 2 is equal to this one multiplying this whole thing and also this one multiplying this. So I have 3x multiplying x minus 4, then plus 1 multiplying x minus 4. Okay, like that. Okay, now let's remove. So here I've got x squared plus 2x plus 2x plus 4 is equal to 3x squared minus 12x, then plus x, then minus 4. Okay, like that. Now simplifying, I will have on the left side x squared plus 4x plus 4 is equal to 3x squared. Then here I've got minus 11x minus 4. Okay, this is minus 4. Okay, like that. Now I can even go further and take this whole thing this side. Okay, so I'll have x squared minus 3x squared, then I'll have plus 4x plus 11x squared, then plus 4 and plus 4 is now equal to a 0. Okay, having that, I can simplify. For the first one here, I'll have minus 2x squared, and I'll have plus 15x and plus 8 is equal to a 0. Okay, so for this, if I want, I can take out a minus there. So if I want, I can take out minus. This is my simplest way of taking out minus here. If I take out minus, I'll have minus for both sides. I'll have 2x squared minus 15x minus 8 is equals to 0. I've taken out minus there. Then if I have that, I can factorize and have this first part as 2x plus 1 x minus 8 is equal to 0, meaning to say the values of x is equal to, okay, let's start it from the basics. We are saying 2x plus 1 is equals to 0, or x minus 8 is equal to 0. Okay, let's use that. So that at the end of the day, we are saying 2x here is equals to minus 1. And our x value at the end of the day, our x is now equal to minus half here. Then on the other side there, we have our x being equal to 8. Okay, so we have two values of x there. So what we now have to do, we have answered for the first part of finding x values. So these two, you will be marked correct, this one and for our 8 there. Okay, so now for us to write the sequence, it's like we are going to have two different sequences where we have our x as 8 and our x as minus half. So I'm going to do the same for these two. Okay, let's do that. So if we substitute our x values into t, let's have our t4 was equal to x minus 4, t5 was equal to x plus 4 plus 2, t6 was equal to 3x plus 1. Okay, let's substitute for x is equals to minus half, and also for x is equal to 8. Okay, let's do that. So I'll have two different answers there. So for the first one, when our x is minus half, then our T4 becomes minus, our T4 is now equal to minus 9 over 2. Okay, our T5 becomes, if we substitute here, our T5 becomes, if you properly substitute, we'll get 3 over 2. Then for T6, so I'm simply doing it fast forward, I'll get our T6 as minus half there. Okay, doing the same for x is equals to 8, our T4 becomes 4 here, T5 becomes 10, T6 becomes 25. Okay, so these are the values that we now have. So with this information, we can find now the common ratio, the value of our common ratio. Okay, so I'm going to find the common ratio for the two. So I'll have for x is equals to 8 and for x is equals to that. Okay, so for this one, r is going to be equal to minus half over, so I'm taking this one and this one, over 3 over 2. What do we get? We will get our r as minus half times 2 over 3. Okay, so this one and this one cancel, so our r becomes minus 1 over 3. Okay, then for 8, we'll have our r is now 25 over 10. So I'll get a 5. Okay, let's have it as an improper fraction. So I'll get 5 over 2. So this is my r. So I'll now have those two common ratios. Now let's go and find the first term. We want to find the first term, I. Let's find our a. So it's going to be a process. We are going to be dividing these two by 8, where we have our 8, our x as minus half, and our x as 8. Okay, so for the first one, T6 is equals to a r to the power of 5. We want to find the value of a. I'm using the 60th term. Then I will get T6, we said it's minus, T6 is minus half. Okay, fine. We have got minus half is equal to a by r. We just found our r is minus 1 over 3 there. So I've got minus 1 over 3 to the power of 5. Okay, so if I multiply this, I will get my a as, 243 over 2. Okay, so this is the value of our a. Let's do for 8. X is equals to 8. So for this side, I'll have my T6. T6 is equals to a to the power of r to the power of 5. Sorry, T6 is equals to a to the power times r to the power of 5. Okay, yes. T6, we got our T6 as 25 is equals to a by r. We say this is 5 over 2 to the power of 5. Okay, so this one, if we simplify, we get our a is 32 over 125. Okay, so if you have problems or challenges with multiplying or simplifying these terms, please follow our video on indices. Okay, that's where we are coming from. So at the end of the day, having our a, remember our a, we said, is also our T1. I can say our T1 for the first one, for the first x, our T1 we are saying is, we have got our T1 as 243 over 2. Then if you substitute, and I'll leave it here so that you simplify, you should get the second term as 8 minus 81 over 2, the other one 27 over 2, and so on. This becomes the sequence. And for this one again, for the 8, x is equals to 8, you get your first term as 32 over 125. Second term, 16 over 25. Third term, 8 over 5. This becomes the sequence, sorry. This becomes the sequence. So please remember, this is T1, T2, T3, and so on. T1, T2, T3, and so on. So this is the sequence that the question was asking us to find. Okay, so please follow our videos and remember to subscribe and share with your friends. Otherwise, bye bye for now.